Bienvenidos, Ushamdid, and welcome University of Maryland Global Campus learners from the CMIT-456 Section 6380 course for the fall 2021 semester. This is the Cisco Networking Academy's Implementing Cisco Enterprise Advanced Routing and Services Version 8 course curriculum, or the CCNP ENARSI course as it's commonly referred to. And in this packet tracer tutorial and activity, we're going to be taking a look at packet tracer activity 5.2.1, where we're now going to be configuring Cisco's enhanced interior gateway routing protocol, or EIGRP, for IPv6, or as it's commonly referred to, EIGRP v6. Now, we're also going to be taking a look at some Wireshark packet captures on real Cisco routers so that we can get a better feel for what the EIGRP neighbor adjacency exchange looks like when two routers come online. And so here's our topology. And a quick note here. Notice that we've got global unicast addresses here, right? Or we have global unicast prefix ranges here for these transit segments between the routers. And a quick note on that. There's nothing wrong with that. However, this is not required for the EIGRP v6 neighbor adjacency to be established or for these routers to route EIGRP v6 packets and IPv6 traffic. So they've got this information here. However, remember, it's going to be the link local addresses that we're interested in, because it's over those link local addresses that the neighbor adjacencies will be formed with EIGRP v6. So that's just a quick note there, because there's a misunderstanding with a lot of learners that you need to have global unicast addresses configured on these links between routers in order for the adjacency between EIGRP v6 neighbors to come up. And that is not the case. All right, so we've got our addressing table here. You can see the link local addresses have already been set. And let's come on down to our instructions. So we're going to enable IPv6 routing on each router. Now, this is still required today. And you want to make sure that you come into global config. And if you're going to be configuring any IPv6 or any routing protocol to support IPv6, you're going to have to say IPv6 unicast routing. Again, this is off by default. Now, I'm going to show you on router 2 what would happen if you tried to configure a routing protocol for IPv6 without IPv6 unicast routing enabled. And it's a great error message. It basically tells you IPv6 unicast routing is not enabled. We need to get that done before we can configure the IPv6 routing protocol stanza. So we enable we enable IPv6 unicast routing, and now we can configure EIGRP for IPv6 on each of the routers. And so if on this router, here's what it would look like. I'm simply going to say, router IPv6, and if I'm going to say IPv6 router, and you can see here, this is our choice of routing protocols. So I can say EIGRP followed by the autonomous system number. And so looking over here, it says that we're going to be using autonomous system number 1. So IPv6 router EIGRP 1. Now, what we might not see, if I say do show run, pipe it to section router EIGRP. Now, this has been something on Packet Tracer that has existed for a while, and I'm running the latest version of Packet Tracer here. It's 8.0.0, and what you're going to see is the EIGRP IPv6 configuration stanza will have this process shut down by default. And there it is. And you can see right down here where as soon as we go into the configuration stanza for EIGRP v6, the process is shut down. And so what you would have to say to bring this up is no shut. Now, this is a remnant of early 15.x, a remnant that goes back into the 12.x train of code where you would have to come in and say no shut. On current Cisco iOS releases, this is not what happens by default. In fact, we'll see I'm running 15.1 code on 2 routers we're going to be taking a look at when we go to look at the Wireshark packet captures. And those configuration stanzas do not have the process shut down. So I would say no shut, and that's going to bring the EIGRP for IPv6 process online on router 1. Now, we've got that done here on router 1. Again, we're using autonomous system number 1. And let's go ahead, let's come over to router 2, and let me show you what's going to happen here if I go from user exec to privilege exec and I say IPv6 router EIGRP 1. Now, we haven't enabled IPv6 unicast routing. Oops, and we should probably try that from global config, IPv6 router EIGRP 1, and it simply tells you IPv6 routing is not enabled. So that's your key to say IPv6 unicast routing. Hit the up arrow a couple times, come on in here, and right out of the gate, we want to say no shut. Now let's do the same thing over here on router 3. Get into global config, IPv6 unicast routing, and then we're going to say IPv6 router EIGRP 1 and no shut. So this brings us back over here to router 1. Now, one of the first things it's asking us to do is to assign a router ID to each router. And we're just simply going to use the router number 4 times, right? So in each octet of the router ID. Now I say octet, but let's keep in mind that it's the router ID while it takes the form of an IPv4 address. It is not. It could be, if we had that configured as a loopback address on this router, it could also look like an IPv4 address, but it is not an IPv4 address. This is not a pingable address. And you're going to see that, right? So I'm going to say EIGRP router ID, and it's just quad ones, 1.1.1.1. So in other words, let's say that a different way. The EIGRP router ID, just like the OSPF router ID, is a 32-bit dotted decimal notation format that is not an IP address. Could it be the same value as an IP address on the router? It could, but it doesn't have to be, because again, this is a router ID. It is mutually exclusive, has nothing to do with reachability to the router, right? This is not an interface, physical or virtual or otherwise, on the router, and that is not an IP address. It is the router ID, which has the exact same format as what could be an IP address. And again, I'll show you when we bring EIGRP up, we can't ping that address because it doesn't exist on the router, right? And it's an IPv4 address on top of that. So again, the router ID for EIGRP v4 and EIGRP v6 still maintains the 32-bit dotted decimal format. So that doesn't change, right? Between EIGRP v4 and v6. The router ID is still the 32-bit dotted decimal value that looks like an IP address that is not, but could be the same value that is being used as an IPv4 address somewhere on the router. And so hopefully that makes that clear, because this always causes confusion with learners as they think, oh, well, I can ping the router ID. Well, maybe, right? Well, and I say maybe because, but it's not, maybe you can ping that address that looks like the router ID value or is the same as the router ID value, but you're not pinging the router ID. You would be pinging the IP address that is the same as the router ID. So I just want to make sure I get that set up. All right, now it says using autonomous system number 1, configure EIGRP for IPv6 on each interface, because what you're going to notice here is there's no network command. So no longer are you tormented with network statements and trying to figure out wildcard masks or dotted decimal notation for subnet masks or doing the quad 0. With EIGRP v6, you simply go under the interfaces. And does it ask you to passive any of the interfaces? Yeah. All right, good. So step 5 is passive the interfaces that face the LAN segment. So let me say do show IP interface brief. And again, I'm not seeing the IP addresses. I just need to see the interfaces that are up because this tells me it's gig 00. So I'm going to go ahead and say passive interface gigabit Ethernet 00, right? And we don't want EIGRP updates going out this interface right here out to the LAN segment because, again, it's a security concern. Now, you're going to hear people say, oh, well, plus it doesn't chew up bandwidth. Well, these EIGRP hello packets are not going to be chewing up the bandwidth on a gigabit Ethernet interface. So more important is, again, that statement's true, right? It's going to use bandwidth, but it's using such a minuscule amount of bandwidth to send the hello packets out here via multicast. So I'm sorry, I'm going to make sure I'm via IPv6 multicast. I thought I said broadcast there. So via IPv6 multicast is where it's going to send these hello packets out here. And the bigger concern is security. We don't want someone to see, maybe they're running Wireshark over here on PC1 and they're going to be capturing these packets. That information we don't want to have shared on the LAN segment. And again, it's unneeded. There's no router out here to which router 1 is going to form a neighbor adjacency. So why would we send hello packets out there? We wouldn't, right? All right, so now this is one of the easiest things to do in IP when we're doing EIGRP for IPv6. So I'm going to go to interface gigabit Ethernet 00. I'm going to say IPv6, EIGRP, and the autonomous system number, and that's it. This is going to enable EIGRP v6 and the EIGRP process for IPv6 to start on that interface. Now, keep in mind, we've passived this LAN interface, and so there will be no adjacency, but now we're going to go into serial 000, and I'm just going to hit the up arrow twice, and that's it. Then I'm going to go into interface serial 001, hit the up arrow twice, and so router 1, for all intents and purposes, is configured. So let's see, can I do any debugs here for IP EIGRP? And it looks like we can only do the summary. Let's see what we see. I'm not sure what we're going to see here when we go to set things up. And again, we're going to be looking at real Cisco routers and Wireshark here in just a second. So here we are here. Let's say EIGRP router ID is 2222. And the LAN interface do show IP interface brief is going to be gigabit Ethernet 00. So passive gig 00. And then we're going to go into gig 00. We're going to say IPv6, EIGRP1. We're going to go into serial 000. And we're going to say, and I just noticed there's a loopback address there. And let's see, do show IPv6 interface brief. And let's see if there is a loopback. Yeah, there is a loopback, but no address. And so we're going to leave that alone. So then we go into interface serial 000. Oops, sorry. And it's just going to be IPv6 EIGRP1. And you can see that that tells us that this is the serial 000 interface here on router 2 because an adjacency has come up. Now, if we go back to router 1, you can see that the summary is not really helping us with anything because we're not doing any summary route processing. There is no summarization going on. So we do see the notification level syslog message here telling us that, hey, an EIGRP adjacency is up. So let's go back to router 2. Let's make sure we finish out the router 2 configuration here. And let's say do show run. And I think we've got all of our interfaces. We need to hit serial 001. Yep, so interface serial 001. And we're going to say IPv6 EIGRP1. And that's how easy it is to enable EIGRP for IPv6 on a router interface, right? Again, there are no network statements anymore. Okay, so that should take care of router 2. And so let's go ahead and say write mem. And what if we were to say show IPv6 route? And you can see that we have learned some routing information. Excuse me. We have learned some routing information via EIGRP. Specifically, this is the LAN 1 subnet here. And you can see 2001 DB8 Cafe 1, which is right here. And then we're seeing the 2001 DB8 Cafe A003, which is this LAN or this transit segment right here between router 1 and router 3. All right, so let's come over here to router 3. And let's go ahead and say EIGRP router ID 3333. And let's make sure do show IP interface brief that we don't have okay, it's gigabit Ethernet 00, so good. So we're going to say passive gigabit Ethernet 00. And at this point, now we're going to go into the interface config mode for gig 00 and say IPv6 router IPv6 EIGRP1. We're going to go into interface serial 000. We're going to say the same thing. And we're going to go into interface serial 001. And we've got all of our adjacencies up right now. You can see the activity is at 100%, but we've got a little bit more work to do here, things that we want to take a look at. So let's go ahead and say IP or show IPv6 EIGRP neighbors, right? And we can see here the link local address of the router, which is our neighbor that we have a neighbor adjacency established with. And you'll notice it's not showing the global unicast addresses. Again, they have these here, but these are not required. If the only thing going on here is it's a transit segment and we're going to have an adjacency across it, the only thing we need at a minimum is a link local address, because it's sort of the same idea as IPv4 addressing, right? We're not trying to telnet to this interface on the router. We'd typically be trying to get to a loopback interface of some kind, right? If you're trying to telnet to the router and you're not routing traffic, and you're not trying to route traffic to this network. And you can see that these really serve no purpose in the topology other than they're just here and they're configured on these interfaces on each side. It's the link local addresses with the IPv6, EIGRPv6 that are paramount, right? And so if we were to try to test connectivity here, if I was to pull this up and let me go ahead, we've got our PCIP addresses there. If I was to say ping 2001 DB8 cafe 1 3, and so that's PC1. And then let's try to ping PC2, which is going to be 2::3, and you can see we've got reachability throughout the network, right? So let's take a look at what a packet capture might reveal with Wireshark here. And you can see we're going to be using, this is, router 9 is here, and there's a CDP, VTP, DTP, PAGP, UDLP, CDP protocol, right? So it's got CDP enabled, and this is the information that we've got for router 9, but we're looking for IPv6 information specifically for EIGRP. So let's jump on to router number 9 here, and let's go ahead and get into global config. Let's say IPv6 unicast routing, and I'm going to go into interface fast Ethernet 00.10. And let's go ahead and say do show run interface fast Ethernet 00.10 because we want to make sure. And there we go, and we could probably get rid of this BFD config, which is sort of a leftover from some stuff. And so here we go. There is the link local address. You can see there's no global unicast address here, right? All we have is a link local address. So let's say IPv6 router EIGRP 1. Now, if I say do show run, pipe it to section router IPv6 EIGRP 1, you'll see that it's empty. We don't have anything configured in here. So let's set the EIGRP router ID. I'll set it to 0009, right? To prove it's not an IP address, and I forgot the router ID there. So we'll say router ID, and it looks like it wants more than that. It looks like it wants the whole thing. There we go. All right, so EIGRP router ID, and then we'll rerun the command that shows us the configuration stanza, right? And let's just pull this back. Shows the configuration stanza, and you can see that you're not seeing a shutdown statement, right? And this is running 15.1 code. So just be aware, in Packet Tracer, for whatever reason, it still leaves the EIGRP process shut down. However, on any recent iOS release, 15.1 and beyond, it's probably not going to be shut down. Now, is the shutdown command still here? Well, take a look. I could come in here and say shut down. Now, how would we see that? If I say do show IPv6 protocols, right? Let's see what we see here with EIGRP. So you can see EIGRP for Autonomous System 1, router mode has been shut down. So here's where you could come in and look to see, right? If you didn't look at the EIGRP configuration, stanza show IPv6 protocols would show you if it's shut down. Because if I say no shut and we rerun that command, does it say that it's shut down here? And you can see that shutdown line is right below the line that says EIGRP IPv6 protocol for AS1. Down here, it's gone, right? And so that's one quick way that you could take a look, in addition to looking into that configuration stanza to see that it was shut down. So again, two ways that you could do it. So now that we've got the EIGRP router ID configured, we've ensured that the process, the EIGRP router mode has not been shut down. Let's jump into interface fast Ethernet 00.10 and let's say IPv6 EIGRP 1. And if we come over here, we should do a packet capture and we'll continue without saving. And what we should see is every 5 seconds, we should be getting an EIGRP hello packet. And take a look at that. So we can like kill this right now, right? So there is our EIGRP protocol. And you can see it's a hello. It's basically router 9, right? Because look at the source. And let me pull the pen out here real quick. So you can see that this is the source and this is the destination as to where these packets are going. And so my source is FE80::9. Convenient that we can look at that and say, oh yeah, that's router 9. And then here is the IPv6 multicast address. That is the destination. In other words, this is router 9 yelling out this segment via multicast, hey, I want to do EIGRP for IPv6. Hello, is there anybody else out there who's interested in doing EIGRP for IPv6 with me, right? And that's that hello packet. And you can see it goes to FFO2::A. And remember, the multicast address for IPv4 is 224.0.0.10, right? So let's take a look here. You can see Internet Protocol. We've got our source and our destination. Oops, sorry. And if we were to drop the little dialog down there, you can see source address. There is the link local address. So nowhere in here is it referencing global unicast addresses. We come down here. Let's take a look. Cisco EIGRP. We can see its version is 2. The opcode, hello message, is 5. Status code, you've got some flags. Autonomous system number is in here, 1. We got the software version information, right? And you could see this information as well from the command line. If you were to, and I'm forgetting the command because this is not one you run. I think it's tech support, show EIGRP. Tech support, let's jump back over here real quick and let me get out of this and let me say show EIGRP. Yeah, you could say show EIGRP plugins. Not a command that you commonly run. Or you could say show EIGRP tech support, another great command, right? And this is going to show you lots of version, and look at that. It's kind of showing you a lot of the same information, but then it gives you a little bit additional information down here at the bottom. And if I was to pull that back, and I think there is it protocols? No, it wasn't that. I thought there was another one. Maybe it was, oh, plugins. There it is. Sorry, it's plugins. And there we go. And again, this is going to show you. And I think I thought the format was a little bit different, but again, it's giving you the EIGRP release information. And this is a kind of an older version of code. These guys are running 15.1, right? So I think right now it's the portable EIGRP release for, I think it's like version 23 or something like that. So it's advanced substantially over the years. So again, a great way to find some additional information about EIGRP, and you can see there, EIGRP version 6 and the TLV version is 3.0, and that is the type length values that EIGRP is based on. And if we look at the parameters here, well, what do we see here, right? Pretty interesting. We see the hold time, and we see the K metric values. And there's this value I've mentioned before, K6, which is not used right now. It's kind of there for future use. And in talking to Donnie Savage, one of the thought process behind K6 was maybe if that's turned on, it would reflect the amount of energy that the interface is pulling, right? And that was just one of the things that might at some point be used for. But again, today it's all about bandwidth, which is K1, and delay. The bandwidth and the delay. So the EIGRP metric calculation for IPv4 and IPv6 classic mode is the same. It's based on the K1 and the K3 value, and the calculation and the equation to come up with that information is the same. And so if you had this information, right, if you're that bad actor sitting out there on the LAN segment behind router 1 running Wireshark, and these messages are being multicast out, you could easily, if you could come up with a virtual machine or something running EIGRP, go ahead, plug some things in, and the next thing you know, you've got an EIGRP adjacency with router 1. You're advertising bogus information, maybe a default route into the EIGRP domain, and that's going to cause problems. And all the information you need to set EIGRP up to do that, right, out on that LAN segment is right here. The autonomous system number is right there. The autonomous system number is there, and the K values are there. So then you're going to go ahead and set things up. And there are ways that you can prevent that obviously if you're going to be setting up authentication between the routers, which is something you would want to do, that you could prevent that. However, in smaller shops, maybe that hasn't been done. All right, well, that is going to do it for this packet tracer activity on configuring EIGRP or classic basic EIGRP with IPv6 routing. Again, remember it's IPv6 router EIGRP autonomous system number. Set your EIGRP router ID. No shut that EIGRP router mode process. If you think it might be shut down, make sure you check and see that it's not. We saw 2 ways to do that. And then you just go under the interface and you say IPv6 EIGRP autonomous system number. And remember, the autonomous system number has to match. Has to match, or the adjacency will not come up. All right, well, thank you guys so much for watching. Let me know if you've got questions on this. And as always, I hope to see you in the next video.